What's going on, guys? Welcome to LetThereBeMath, and in today's video we're going to be talking about how to integrate exponential functions where the power is a linear function of x and the base is any arbitrary base we choose, particularly just a positive base a. Now in this case what we would like to do is, well, we already know that the integral of something like this, e to the power of ax plus b, is going to be equal to just 1 over a times e to the ax plus b plus c. So this is what we were looking at in the previous video, and we found that by simply differentiating the functions e to the ax plus b. Now what we would like to do here is we would like to have something similar but for any base a we choose, just to generalize things further. So what we're going to do is we're going to do a very nice trick that I like to do with these kind of problems, and we're going to start off by writing out a function y equals to a to the power of bx plus c. Alright, so basically what we have here is we have a simple function a to the power of bx plus c, and we would like to somehow convert this into base e, because we already know how to integrate that. So it would be marvelous if we could just simply do that transition between those two. Now one thing we can do is let's apply a log base a of both sides. So log base a of y is now equal to log base a of this whole expression. Now we're gonna first use the first property of logarithms, which says that if we have an argument where there's a power, the power is going to come to the front. So now we can write that down as bx plus c as a factor, and then we have log base a of a. Now the second property of logs that we're going to apply in this case is going to be the fact that when you have the argument is equal to the base, this is going to become 1. Okay, so that's going to be another log property we're going to use. So now we basically end up with the following expression. We have log base a of y equals to bx plus c, where a, b, and c are constants. Now the next thing we want to do is we're going to apply a very common result from logarithms, and it is that we have a general formula for the change of base. So let's say we wanted to change from something that looks like this. So we have an argument a and a base b. Then we can change this into any other base. I'm gonna call it log c, by basically taking the same function a, or the same argument a, and we're now going to divide it by log base c with the old base as the argument. So this is the general formula for changing the base of a logarithm. And we're going to apply that in this case. So which base do we want to change this into? Well, obviously base e, so we're going to use the natural log. So let's change the left hand side of that equation by using this formula over here. And that's going to be natural log of y divided by the natural log of a. And that's going to be equal to bx plus c. And now for the final step, what we can do is we can multiply both sides by natural log of a. So we have ln y equals to natural log of a times bx plus c. Okay, remember this whole thing here is just a constant. And the final step is to recover the y function. Is we're simply going to use y is going to be equal to e to the power of the natural log of a times bx plus c. Okay, so that's essentially going to be the exact same function. How do we ensure it is indeed the same function we started with? Well, we can test this out by using the properties of logs. Bx plus c is a factor multiplying natural log of a, so that means we can also bring it into the argument as a power of a. So if we were to write y equals to e to the power of the natural log of a to the bx plus c, what that would basically mean is that we now have an expression in which the base and the natural log here cancel out, and that's going to give us just a to the bx plus c. Okay, so that recovers the original expression. Now, I know this seemed like a long derivation, but we went through the whole thing step by step, and hopefully that shows how this transformation occurs. So now let's apply this whole thing again. So let's go back to the beginning of our whiteboard here, and we're going to look at how to transform this function. So the first thing we want to do is we're going to use this result we just found. So this integral over here is going to be the same as the integral of e to the power of ln a times bx plus c dx. Okay, so now that we have that, well, that's quite simple because this has exactly the same form as that integral. We just have to multiply the coefficient b by the natural log of a. So that's going to become the integral of b natural log of a times x, and then plus c natural log of a dx. And now what's that going to become? Well, we're just going to divide this by the power or the coefficient that is multiplying x, and that's going to give us 1 divided by b on times ln a, and then times e to the b ln a x plus c ln a. And then for the integration constant, since we're already using c as one of the coefficients here, we're just going to use k as the integration constant. Okay, so that's our final expression. Now, of course, this is not very useful if we want to express the answer in terms of the original function, which was a to the power of bx plus c. So let's change that back by performing the same manipulation. So now we're going to go back here. We're going to simplify this by writing 1 over b times ln a. And here we're just going to have natural log of a times bx plus c plus some arbitrary constant k. And now we're going to bring this coefficient bx plus c as a power inside that argument. So that's going to be 1 over b ln a times e to the natural log of a to the power of bx plus c plus the constant k. And then finally, we know that since we're raising e to the power of the natural log of the same base, these two cancel out. And we're going to be left with a to the power of bx plus c divided by b ln a plus the constant k. And that's going to be the final answer. So hopefully in this video you saw how you can actually perform this type of integration with any base that you choose simply by using the properties of logarithms. In the next video we're going to continue with some more examples of this formula and how to apply it to more complicated exercises. As always, if you guys enjoyed the video, make sure you hit the subscribe button, and I will see you guys in the next video.